Okay, now let's go on to question 6. It says a man makes a parachute jump. Initially, he falls without opening his parachute. Then he opens his parachute fully and falls to the ground. So it shows figure 6.1 shows how his speed changes with time, with jumping. Now, if you look at the whole thing here, you need to think about it. When he opens his parachute, how would his speed looks? Okay, what will happen to his speed? So think about it. If you think carefully, looking at the whole juncture here, the only possible place where he would have opened his parachute would be at this point. So this is the point where the parachute opens. Okay, because you can see there's a sharp drop in the speed. The only possible for this kind of sharp drop is either parachute opens or he hits the ground and he dies. But it doesn't make sense that he dies because can you see he's still traveling over at this segment over here. He's still moving. Hence, this is the only possible reason here is that his parachute has opened. Now, in part A, it asks, state two time intervals that the man has uniform acceleration. So if I look at this whole graph here, okay, if we ignore that, zero speed is uniform acceleration, we just focus at the part where the graph has a straight line. There are two segments. Okay, the first segment is over here. Okay, from 0 to 20. T equals to 0 seconds to t equals to 20 seconds. The other one will be over here. Okay, so we have t equals to 70 seconds to 74 seconds. So that's the two time interval that a man has uniform acceleration because you can see that there's a straight line over here. Okay, a straight line over here. Now, the next they ask, state the time which the man opens his parachute. We already highlighted at this point over here. So at t equals to 70 seconds. Now, part C asks us calculate the distance through which the man falls between 50 and 70 seconds. So let's also find distance. Oh, sorry, wrong part. Let me erase this again. So let's find the distance covered here from 50 to 70. What is the distance covered here? So for any speed time graph, we know that, to calculate the distance is actually the area under the graph. Okay, to be exact, is area under the speed time graph. So to find the area over here, okay, we know that this is 20, this is 50. So can you see this is actually a rectangle? So to find the area of the rectangle, I'll just take the base times the height. So it's 20 multiplied by 50. What I'm going to get is 1,000 meters. So the distance covered is 1,000 meters. Relatively simple question.